Oh, wait. Now.
This is lesson 1.6, solve algebraically.
I'm Leslie.
Okay, y'all gonna feel real bad once you guys can watch this video.
You don't know.
I know, I'm just picking Okay. All right. So yesterday we talked about graphically. We've talked extensively about our calculators today. Today we're going to go algebraically. I hope you remember how to do this. There are two methods. There is by substitution and elimination. We'll talk about substitution first. The goal here is still the same. We are looking for a point of intersection. We are looking for a shared point, a point that makes both equations true. Okay? Keep that in mind as we go. A lot of Algebra 2 is putting different methods together for doing the exact same thing. So remember that, and I think you'll be a little better off. All right, let me give you a system. Let's say, let me find one that's going to work out well. 5x minus 3y equals 23. And 2x plus y equals 7. So I want to know what point satisfies both equations. So for substitution, what we're going to do is, and I'll write the steps. Do y'all remember doing this in Algebra 1? Yeah. Okay. I heard one no. Everybody else said yes. Yeah, no. Okay. So here's what we're going to do. The first thing we're going to do is we're going to solve one equation. It doesn't matter which one, but us being the intelligent algebra students that we are going to know which one to pick. We're going to solve one equation for a variable. So notice I didn't say what variable. I didn't say what equation, because that, my dear friends, is up to you. I'm going to look smartly at my two equations given and say, of those two equations, which one is easiest to get a variable by itself? The bottom one to get y. Y is that the easiest? Because there's no coefficient on there, right? Y is already by itself. It is a one-step solve there. Do we all agree? Yes, ma'am. If I do this one, to get y by itself, I simply subtract 2x. And so I get y equals negative 2x plus 7. Is anybody confused with that? Exactly. The reason that this is called substitution is because I take that value and sub in. I think I'm going to get on Amazon and order me a new pen. Sub in. No, they're expensive. I appreciate it. Solve in the other equation, okay? So it's important that you go back to the equation that you have not already touched or done anything with, and we are going to plug in. And I would advise you to put it in parentheses so that you don't lose any signs or anything.
Is that saying take both variables?
Take what you got in step 1 and sub it into the other equation. So the other equation is 5x, bless you, minus 3, except instead of y,
it will be negative, parentheses, negative 2x plus 7.
That is correct. It still equals 23. Remember my goal. My goal is to find an x and a y that satisfy both equations. So for this, I need to do, what do you think? Distribute. So what are you doing by distributing? Right. You're solving for whatever variable is in there. I'm not going to say solve for x because you might not, it might be all y's in there, okay? Hopefully, this is an easy solve for you. Why we spent some time in the beginning talking about solving equations. I'm going to distribute. This is going to be a plus now, right? Because it's negative 3 times negative 2 minus 21 equals 23. Get your x's together in the same room. Ha!
That was a good joke.
I caught that after you started.
Yeah. All right. Add the 21 and then do what? Exactly. Am I going too fast through those? This is too slow.
No, do not go any faster.
Keep going faster. I already sold, same speed.
All right, when I divide by 11, I get x equals 4. All right, now, at this point, hold on.
I didn't understand that.
Why, what just happened?
He just came in and sharpened his pencil. Miss had to have him sharpen. If x equals 4, okay, that's half of my solution. I need the y, right?
Plug it into the equation you already found.
Exactly. That's exactly what I would do. Look at the equation that you already solved for a variable. You already have y by itself. Now, it doesn't matter. I'm going to say plug in
No, one half.
to find the other. No graphing. It is, in my opinion, smarter to use the pink equation there because it's already solved for y. -2, it's not x, it's 4 plus 7. So I have -8 plus 7, which is -1. Okay? Just because it's already solved there, there's not a lot more manipulation that you would have to do. So what this tells me is that these two lines intersect at the point 4, -1. And if I were to graph it, and I'm not graphing because it's solved by substitution, but if I were to graph it, then yes, they would intersect at the point 4, -1. Does that make sense?
Yes.
Okay. It could get a little more sticky with some fractions. We hope not, but it could, but the method is the same. Does that make sense to everybody?
Yeah, we're good. Well, I'm probably just changing to adjust.
All right. Let's run through elimination. And the reason that I'm kind of just skimming through, these are really, we've done this before. I'm just refreshing you. If you don't remember or need some extra help, please stop me and let me know. All right. Let's do elimination. Method 2. Substitution's always my favorite. Elimination's a little bit easier sometimes. It's not quite as messy. Elimination. Now here's the goal. You have to think about the goal at the beginning here whenever you look at elimination. So let me write your goal. Your goal, come on. I'm just going to have to write really slow. Your goal is to add the equations together and have one variable cancel out.
Oh, yeah, I remember this.
How might variables cancel when you add them? Exactly, they're opposite signs. So -2x and +2x, okay? Now, they might be set up to where they will do that on their own, or it might be that you have to multiply one equation through by something, or maybe you even have to multiply both equations through by something. So let me give you an example of what this might look like. Let's do one where we have to multiply through. Oh, they're trying to be nice to you in your homework. No. Let me do one that requires a little more thought than that.
Are you going to give us ones that are graphing tonight? Because we did a lot of that last time.
No graphing tonight, no.
Okay.
6x minus 4y equals 30. And 12x plus 5y equals -18. Okay. So if I add them, and be careful because if they're not in the same form, you'll need to manipulate them to be in the same form so that they line up, right? If I add these together as they sit now, will anything cancel out? I need one of them to cancel out. It doesn't matter which one. I would multiply the top by -2 as well. What are you trying to cancel out if you multiply the top by -2? The x's. Okay? If you tried to cancel the y's here, you would end up having to multiply the top and the bottom by something. You'd multiply the top by 5 and the bottom by 4. Does everybody see that and see why?
Yeah.
Okay. This is an easy one. If you can ever just multiply one equation, of course you want to choose that because that's less work, right? Less work is less places to make mistakes. So we're going to multiply through. I guess I should put that in. Multiply. I don't know how to really word this. I'm going to say by what's needed. Because you really just have to look at it to tell. So negative, watch that sign because I am multiplying through by a negative. Negative 12x plus 8y. Negative 60. Now what?
Cancel.
Cancel.
You add the equations. Okay? Because both equations, each side is equal, we can add them. We're really adding the same thing to each side. So it allows me to add the equations this way. The 12x's cancel because they are opposite signs. What is 5y and 8y? 13y. And negative 18 and negative 60. What was the point in doing that?
To get the Y
To get the y by itself. That's exactly right. So then I want to solve for that particular variable. And what do you get? That's half the answer.
Yeah, and then you just plug it in, wouldn't it? You just plug it in.
Pick one to plug in. It doesn't matter which one. Whichever equation looks the best to you. I'll go with the top one. 6x minus 4, it's not y anymore, it's negative 6. X plus 24 equals 30. What do you do? Subtract 24. X equals 1. So what is my solution or my point of intersection here?
1 negative 6.
Tell me what you think. Do we need another one, or y'all okay?
This is better than graphing.
It's better than graphing.
So the test would be there.
What if when you're solving, either by elimination or substitution, let's say you add the equations together and you get something like this. That's exactly right. That's your infinitely many solutions. That's the one that's the same line.
Wait, what did you just do?
What if you're doing elimination and you add the two equations together, and when you add them, you get something like 5 equals 5 or 0 equals 0. And that's infinitely many solutions.
So what do you put?
Infinitely many
You
solutions.
don't put like a point or anything?
Because it's the same line. If you add them or you go to solve and you get something like 2 equals 7.
Inconsistent and dependent.
No solution. Yeah.
What is that?
Just if this comes up, I just wanted to have a little blurb here. Most of you probably would figure that out. 2 equals 7. If you just get something that's not true. It's awful. Like, this is the worst it's ever been.
That's crazy you've gone through that.
Or, because yes, the variables are the same. Okay, so for instance, here's one.
Is this in substitution or elimination?
This is elimination. But it can be both. Most of the time you're going to see it better in elimination. Negative 35x. This pen, man. 40y. This is one of your homework problems, but I won't tell you which one, so you better write down. What is it doing?
It's glitching. The FBI is hacking you. This is when you
Because the FBI doesn't know how to solve systems by
This is when you
elimination.
type in computer, hey, Mr. FBI, stop my computer.
All right.
Use your finger.
Yeah, but it doesn't work well in this software. That's why this is a special stylus. It's a smart
You need
stylus.
to get yourself a good iPad with
Yeah. You're one of those.
Apple pen. Those apple pens.
Maybe it's because it's recording, because I hit stop record and then I was able to write. All right, right. So what happens when you multiply, guys, when I multiply this one through by 5, I get 35x minus 40y equals negative 55. When I add it to the first equation, I get 0 equals 0. So that would be infinitely many solutions.
55.
Okay.
Right.
Yeah, it's 55.
Oh, yeah. Sorry. Now, if I had done this and I got, let's say on this right, let's say that was 50. And I got negative 5 on that side and I had 0 equals negative 5, that would be no solution. Okay, because that's never true.